Alright, so these are numbers 6 through 10 on this video. So let's go ahead and solve for x and look for extraneous solutions. Alright, so the absolute value is isolated. Okay, so we're going to go ahead and do the breaking up into two versions right now, both the positive and the negative forms. So we have 4x plus 6, 4x plus 6. And right here, what we see, we're going to have the positive form and also the negative form of the right side. And because of this negative, we need to remember with absolute value, this is commonly forgotten, is that we need to remember to flip the inequality sign. Okay, so now we're just going to do Algebra 1 and solve for x. So we'll subtract 6 from both sides. We'll get this. We'll subtract 6 over here from both sides. And we get that. Dividing by 4, this will go to 1, or 1x, and this one will just go to 1. And then dividing by 4, this is a form of 1. This will be a negative 4. And again, we do not flip here, even though we get a negative. We only flip the inequality if we're multiplying or dividing by a negative. Okay, which is not what we did there. So there's our answer. And if I graph it immediately, I have 1 and negative 4. And here we go. We're going to, because this is equal to, we're going to have a closed in dot at 1. And this is greater than, that means we're going to shade to the right. And then a closed dot, because this is equal to at negative 4. Because this is less than, we're going to shade to the left. In other words, we shade all the x's that are less than negative 4. So my graph is going to look something like that and like that. Okay, so this is a disjunction, which means it's or, and it would be x's that are greater than or equal to 1, or x's that are less than or equal to negative 4. Okay, so now let's check for extraneous solutions just to make sure everything is good to go. Okay, so checking for an extraneous solution, let's try something that is either in any one of these to check if it's correct, or in something that it's not, where it's not supposed to be correct. So let's try and check, let's say 0, since it's between this negative and this positive number. If I were to put 0 here in my original equation, 0 times 4 is 4, or sorry, 0 times 4 is 0, plus 6 is 6. The absolute value of that would give me 6 on the left. And 6 is not, this is not true, and that means that this is correct, because this isn't supposed to work out because it's not in the shaded region. Our shaded regions of the answers that we're showing that they would are just on this disjunction right here. Now let's check with our calculator for extra practice. Alright, so we have, here we go, on a document, oops, go back. So on this document, on the first page, we're going to go Menu, Algebra, Solve, and we're going to solve for, we're going to solve for the absolute value of 4x plus 6. So here's that absolute value key, 4x plus 6. Kick out to the right. We're going to say is greater than or equal to 10. So control equals, there's that greater than or equal to sign. And at the very end, we have to remember to put comma x, because we're telling it what to look for. Sure enough, you get x is less than negative 4, or x is greater than 1, which is correct. Let's go to 7. So it says a bicycle engineer uses the following guidelines. Okay, so you are looking at answers that exist with W between 19.82, like an endpoint, all the way to 20.18. And again, it's including both sets of endpoints. So you're saying here, here, and everything in between. For the width W in inches of each tire's diameter, okay, write the specification as an absolute value inequality. So if this is the range basically that I'm looking at between 19.82 and 20.18, there is a center somewhere here. And the way I can find the center, otherwise the average, if you will, between two numbers, is to add them together and divide by 2. Okay, so if we add them together, we would get, let's go ahead and do this by hand, and we'll verify with the calculator. So you have 10, carry the 1, another 10, carry the 1, another 10, carry the 1, we have 40. So 40 divided by 2 should be 20, or 20.00. Okay, so 20 is my center. So I know it's going to be either, whoops, try a different color. It's either going to be A or it's going to be D, because 20 is the center. So it's not these. Now the jump that they have away from the center is basically the distance from 20 to 20.18, or the distance left to 19.82. And sure enough, that distance is 0.18. So it's going to be this one. Okay, because this one doesn't have 0.18, it shows a jump of 0.36. So D would be the correct answer for this one. Alright, find the domain and range of the function that you see. So the domain and range here, first of all, we're going to graph this, and most likely this will be without a calculator. So let's look at this. And in BCAD order, we're going to list these in order of how they occur. So the first one would be this 3, which is a horizontal shift, because it's adding or subtracting, but it's a left 3 because you do the opposite when you're with X. And then this one right here, there's no B and there's no A, so you're going to go straight to D. And this -2 is a vertical. Let me just write these out. So horizontal, vertical shift, because it's adding or subtracting, and then it's down 2 units. Because with Y, you follow the rule. Okay, so looking at a default absolute value equation or a function, let's go ahead and do these transformations, so just so you can see it in real time. Alright, so from here, let me move this just a little bit. From here, we're going to horizontally shift 3 to the left. So 1, 2, 3, and then we're going to vertically shift 2 units down. 1, 2. So 1, 2, 3, and then 2 units down. This looks like the vertex will be -3, -2. And then the domain, scanning this with a vertical line, left to right, it will basically be everywhere. So the domain is all real numbers, or if you wanted to put it in interval notation, would be this. And then the range, you would scan this with a horizontal line from bottom up. It looks like it would start at -2 and go to infinity, touching -2. So you could write this also as an inequality, y is greater than or equal to -2. And that's it on that. Number 9. Number 9, explain how the equation of the line of symmetry relates to the equation of the absolute value function. So with these letters that you're given, we're wanting to know what does it look like if they're not numbers, that you're still going to explain how the line or the equation of the line of symmetry looks like, as far as like with letters. So let's go ahead and do this. So let's say that I have a graph and it starts at the absolute value of x, and from here it says -a. Okay, so what this is saying is, since it's -a, a is going to be moving to the right. So it's a horizontal shift, if you will, a units to the right. And then it's, because it's a positive b, will be a vertical shift b units up. So explain how the equation of the line of symmetry, remember the line of symmetry normally starts at 0 because there's usually nothing in here but just absolute value of x. There's nothing in there with that x. But because I have this -a, that means I'm going to move to the right a units. my axis of symmetry would be x is equal to a. Okay, so let's say a was 3. You'd move 3 to the right, and now your graph would look like this. And there's your axis of symmetry, otherwise known as the center. And you would say x equals a. And then you could say that it was shifted b units up. But because the only reason why it's asking about the line of symmetry, you're only going to describe that line of symmetry as x is equal to a. Last question on this video. Find the minimum value of this graph right here on the interval from -3 to 5. So first of all, let's graph this. It looks like it was shifted 4 to the right and then 4 up. Okay, 4 to the right and then 4 up in, again, BCAD order. And it would look something like that. There were no reflections whatsoever. But we only want to graph on this interval between -3 all the way to 5. So 5. So from here at -3, since there's a bracket, it's going to be a closed dot, all the way to 5, since there's another closed bracket, it's going to be a closed dot. We're only looking at the graph on that interval. So that means we would erase all of this other stuff. Okay? And it looks like the graph would look like that. And it would still go to the left forever, but that's my graph. So if I'm looking at the minimum, I obviously know it occurs here at 4. So you can make yourself a little chart if you wanted to, just to double check like you did on Pearson homework. And you could put like 4 and then things to the left or to the right of 4. Like 5, 6, and then 3, 2, 1, so on and so forth. So plugging in these values into the original equation, 4 minus 4 is 0, absolute value of that is still 0, I would get 4. But if I put, let's say, 5 in there, 5 minus 4 is 1, absolute value is 1, plus 4 is 5. So at 5 it would be 5. And at 3 you'd get 3 minus 4 is -1, but the absolute value of that is a +1, plus 4, you'd go back up to 5. So, and then yes, this would say 6 and 7, and this would say 6 as well. Okay? So as far as that goes, the minimum value, again, is referring to, we talked about this a lot in quizzes and homework and whatnot, is the y value. So find the minimum value. The minimum value is this one right here, which is D, 4. Just make sure that you understand that it's pertaining to the y value and not the x value.